Four-way switches can be confusing just because of the number of wires involved. Let's break down four-way switching in a way that actually makes sense. We'll look at a circuit diagram, a practical example, and we'll talk about a few common pitfalls. Hey, my name is Dustin. I'm a licensed master electrician. Welcome to this episode of Smarter Sparky. Before we look at diagrams, let's talk about how a four-way switch is set up electrically. A four-way switch has 4 terminals, and unlike a three-way switch, it does not have a common. All 4 terminals are travelers. 2 travelers go to one three-way switch, and the other 2 travelers go to the other three-way switch. All four-way switches have to be accompanied by 2 three-way switches. Four-way switches cannot be used on their own. Electrically, a four-way switch doesn't turn power on or off. All it does is redirects the travelers. In one position, the travelers are connected straight through. In the other position, the travelers are crossed. That's it. A four-way switch only changes how the travelers are connected. So on this switch, one pair of travelers is black and the other pair of travelers is gold. Some switches even label them as input and output, but it will work fine if you hook the input to the output and vice versa. The important thing is that each pair of travelers stays on the same set of terminals. So the gold set of terminals is one set of travelers, and the black set of terminals is the other set of travelers. To see the difference clearly, let's look at a three-way switch and a four-way switch side by side. The three-way switch has a common terminal that connects to either traveler. The four-way switch has no common. It only swaps how the travelers flow through this switch. Now that we understand the travelers and the terminals on the physical switch, let's look at a four-way switch circuit on paper. This diagram shows 2 three-way switches with a 4-way switch in between. You can see the travelers running from one 3-way switch to the 4-way switch and from the 4-way switch to the other 3-way switch. In one position, the travelers go straight through the 4-way switch. If we flip the 4-way switch, however, it crosses the travelers. We can trace the path from the hot side of the circuit through the switches to the light. Whenever there's a complete path, the light will turn on, and if the path is broken at any switch, the light stays off. So if we go back in our diagram and we look at this first scenario, if we follow our hot out of the panel and we hit this first 3-way switch, remember, 4-way switches only work when they are started and stopped with a 3-way switch. You will never use a 4-way switch all by itself. So if we follow our hot out of the panel, we see we hit this first 3-way switch and we end up on this black traveler. And if we follow it through the 4-way switch, it goes straight through and continues out on the black traveler. But this other 3-way switch over here is actually dead-ended at that black traveler. So in this case, there is an incomplete circuit here and that light would not turn on. Now, we could remedy this by flipping this 3-way switch. Now we could see we've got a complete path there. But we could also do that with the 4-way switch. If we simply flip this 4-way switch like so, it crosses the travelers, and now we can see that hot will come out of the panel, go up on that 3-way switch. Now it's gonna crisscross on this top paddle right here and continue along now this red traveler onto this 3-way switch, and now we have a complete circuit. We could turn this light off by flipping any one of these switches again. Let's, in this case, flip this first 3-way switch. Now we can see power comes out of the panel, goes through this first 3-way switch down to this red traveler, but at the 4-way switch, the 4-way switch swaps it from this red traveler up to this black traveler, which is now dead-ended. So we can see all these switches do is just route the travelers. That's the whole story of how 3-way and 4-way switches work, is we're just simply rerouting those travelers. We could turn this circuit back on by flipping this 4-way switch, or again, any one of the 3-way switches would also do it. So now in this case, our hot is coming out of the panel, down this 3-way switch onto the red traveler. This 4-way switch is keeping it on the red traveler, and then this 3-way switch here is taking it from that red traveler and putting it on the common, powering our light. If you need to control the light from more locations, you can add another 4-way switch in between the first 4-way switch and the last three-way switch. And again, it's just a simple matter of tracing out these routes and seeing if we have a complete circuit. Any one of these switches could be flipped. For example, in this case, we could flip this new four-way switch that we added to this circuit, and our hot would come out of our panel, up this three-way switch, through this four-way switch. This four-way switch swaps them onto this red traveler, and then this three-way switch takes it from the red traveler, puts it on the common, and lights up our light bulb. If we were to flip this four-way switch, now our hot comes out of the panel onto the black traveler from this three-way switch. This four-way switch swaps it over to the red traveler. This four-way switch swaps it back to the black traveler and dead ends at this three-way switch. And again, flipping any one of these switches will actually swap the travelers that are used. Let's switch this three-way switch. Now we're coming out of the panel onto this red wire. This four-way switch is swapping it to this black traveler. This four-way switch is swapping it back to the red traveler, and this three-way switch is sending it out to the light bulb. We can actually add as many four-way switches as we want or need to get the job done. Here we've got an example of having 3 four-way switches, and we'd actually be able to control this light bulb from 5 different locations. Now let's see this in action with a simple powered demonstration. I've set up 2 three-way switches, a 4-way switch, and a battery in this small little circuit here so we can actually see the light respond to different switch positions. As we flip the switches, we can see the light turns on or off depending on the combination. Each time any one of the switches is flipped, it simply reroutes which traveler is carrying that current or potential. And we can try all sorts of different combinations, and we can see it doesn't matter what switch we flip, it changes the state of the circuit. One thing to keep in mind, most customers like it when all the lights are off, when all the switches are down. In this demonstration, one of my switches has to be in the up position for the light to turn off. Some customers might see this as a problem, but the solution is simple. We could simply swap any 2 travelers on any of the switches. So we could swap, for example, this red and this black, or this red and this black, or this red, this black, this red, this black. Doesn't matter which 2 we swap, so long as we only do it to 1 pair of travelers. I left it this way in this demo so the wires wouldn't cross each other on the board. I wanted all of these wires to be nice and flat on the board so you can clearly see where everything is routed. If I was to swap 2 of these, the red would cross the black on the board and it wouldn't look as neat. Also, I don't show any equipment grounding conductors here, but in a real installation, it would still need to be connected along with these other conductors. One common error is mixing up the travelers and commons on a 3-way switch. If these aren't connected correctly, the circuit may work in one switch position, but it won't work in another switch position. Another issue that can happen on a 4-way switch is accidentally dividing the travelers incorrectly. Each pair of travelers needs to stay together on the correct set of screws. If we mix them up, the switch won't route the current properly. For example, if we were to swap this red and this red, the circuit would act really strange. It might work in one combination of switches, and it might not light at all in another combination of switches. Remember, the black terminals are one pair of travelers going to the next switch. The gold terminals are another pair of travelers going back to the other switch. Sometimes people accidentally use a 2-pole switch instead of a 4-way switch. I've actually seen this happen on a job site. They can look very similar with 4 terminals, but a 2-pole switch will usually have the words on and off written on the switch. Notice on a 4-way switch, there is no on or off wording written on the switch. Just like on a 3-way switch, it will not say on or off. So if you grab a switch that has 4 terminals and it says on and off on the switch, that is not a four-way switch. That's probably a two-pole switch, and they work completely electrically different. Older four-way switches can also be tricky. They might be poorly labeled, or the screw terminals might be on the sides instead of the top and the bottom, so it's easy to get confused. If you wire up a four-way switch and the circuit's not working and you're pretty sure you got the terminals on the top and the bottom, some older four-way switches, and unfortunately I don't have one here to show you, they might have the black screws on this side and the gold screws on this side. So just because in this example the traveler pairs are on the bottom and the top doesn't necessarily guarantee that that's how your particular four-way switch works. Most modern four-way switches that I've seen have been a pair on the top and a pair on the bottom, and they've gotten really good lately about labeling the input and the output. Again, it doesn't matter. We could have the switch installed this way, or we could have the switch installed this way. Electrically speaking, it does not matter which one's the actual input and which one's the actual output. The only reason they do that is so it's abundantly clear where each pair of travelers actually needs to land. Finally, it's important not to assume that wire color guarantees correct connections. Unfortunately, some three-way and four-way setups use the white wire as travelers or commons, so relying on color alone can lead to mistakes. Now that's a whole other can of worms that we can talk about in a future video. There are some unconventional three and four-way systems that have been used in the past and may still be used today. So if you run into those situations where they've used wires incorrectly that we wouldn't do today, that can definitely make it a lot more confusing when you have to re-identify such circuits. The focus of this video is conventional four-way systems, and that's again what we have right here. Again, we can cover more of those exotic methods in a future video. That's a look at four-way switches in action. The main thing to remember is that four-way switches redirect travelers between two three-way switches, letting you control a light from multiple locations. Four-way switches are not used on their own. They always have to be accompanied with two three-way switches, one at the beginning of the circuit and one at the end of the circuit. Be mindful of common wiring mistakes. Make sure travelers and commons are correct. Watch out for miswiring the four-way, and double check switch types and labeling. If you made it this far, consider liking and subscribing. Thanks for watching, and I'll see you on the next one. Bye.